all, my name is V. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about lossy and lossless image compression. So, what are the differences of lossy and lossless compression? How they are related to the image we will discuss now. There are two types of image file compression algorithms. That is the error-free, that is lossless, and the lossy compression. So, these are the two types of image compression techniques are there. So, what is the lossy and what are the lossless compressions are there? So, lossless compression is nothing but it is an algorithm to reduce the file size while preserving a perfect copy of the original uncompressed image. Lossless compression generally but not always results in larger files than lossy compression. Both are very common in use. An example of lossless compression is zip archive file and an example of lossy compression is a JPG file. So, when we are going for the lossless image compression, lossless in the namesake only, that meaning is there, we are not losing any of the image or any data from the original image. Okay? No loss of data. From original image. So, lossless compression algorithms reduce the file size while preserving a perfect copy of the original uncompressed image. So, lossless compression generally but not always results in larger files than lossy compression, but both are very common in use. For example, if you are taking the lossless compression and lossy, so when I am going for the lossless examples, lossless are the zip files. Okay, so lossy are the JPG files. So these are the best examples of lossy and lossless. So majorly lossy and loss compressions are two types. So these are under image compression. Mainly image compression has a two types. First one is a lossy compression. Second one is a lossless compression. Lossless compression is best example is a zip files, and the lossy image compression is a JPEG files. So, image compression involves reducing the amount of data required to represent digital image. This is done by removing redundant information. Image compression is crucial for efficient storage, retrieval, transmission, and manipulation of images. More generally, data compression involves the efficient representation of data in digital format. So, when we are going from the information theory, a field pioneered E. Shannon in the 1940s is the theoretical basis of the most data compression techniques. So, when we are going for the lossy and lossless, these are the image compressions. So, these image compressions involves in the reducing of amount of bits, data or bits. So, these are the lossy or lossless. Lossy or lossless. Okay. So, image compression is crucial for efficient storage, retrieval, transmission, and manipulation of images. More generally, data compression involves the efficient representation of data in digital format. When we are going for the information theory, so information theory is nothing about the data representation. So, a field pioneered by Claude E. Shannon in 1940 is the theoretical basis for most data compression techniques. So, compression can be either lossless or lossy. In lossy compression, one can achieve higher levels of data reduction with less than perfect reproduction of the original image. So, when we are going for the data compression, refers to the process of reducing the amount of data required to represent a given quantity of information. Various amounts of data may be used to represent or describe the same information. Some representations may be less efficient in the sense that they have data redundancy. So, any of the data, lossy or lossless, these are under data representations. Data representation. So, These compressions can be either lossless, information preserving, or lossy. In lossy compression, one can achieve higher levels of data reduction with less than perfect reproduction of the original image. And data compression refers to the process of reducing the amount of data required to represent a given quantity of information. So, various amounts of data to be used. So, what are the various amounts of data? Means there are different types of data representations to be there that can be used to represent or describe the same information. Some representations may be less efficient in the sense that they have data redundancy. And when we are going for the data compression, refers to a technique that allows a large file to be reduced. A smaller size, it allows to decompress the compressed file back into its original form. When lossy compression restores the large file to its original form with some levels of loss in data, which can be considered negligible, while lossless compression restores the compressed file to its original form without any loss of data. Read through this article to find out more about lossy and lossless compression techniques and how they are different from each other. We'll discuss. So, if I'm going for the lossless, okay, the meaning is lossless means no data loss. Lossless nothing but a no data loss. So, that means data restores. Data will be restores when the larger files also. So, the data compression refers to a technique that allows a larger file to be reduced to a smaller size. It allows decompression, the compressed file back into its original form. So, when we are going for the lossy compression, lossy means the image will be lost, means there is no restore of the original data. Okay, we are not getting any loss of information. So, lossy compression restores the larger file to its original form with some levels of loss. Okay, some levels of loss. The data loss will be there. Okay, loss will be occur. The data loss to be occur in the data which can be considered negligible, but a small amount of data, small amount of data. But while lossless compression restores the compressed file to its original form without any loss of data. So, image restoration, the data restoration will be available when the data is lost or data compression is restores. The data will be restores, the compression is restores, that is a lossless. Okay, we are not getting the data back or small amount of data will be lost, that is a lossy image. So, lossy compression. We are going to this one, the lossy and the loss compression techniques and how they are different from each other. We will discuss now. So, what is the lossy compression? So, lossy compression is a type of data encoding and compression that intentionally discards some data during the compression process. The lossy compression methods filters and discards unnecessary and redundant data to lower the quantity compressed and then executed on a computer. Digital multimedia such as audio, video, photos and streaming data benefits from lossy data compressions. The sizes of these forms of data can be significantly decreased by utilizing lossy compression, ensuring convenient internet distribution of or offline consuming. So, what is a lossy compression? Lossy means data may be lost. Data may be lost. Okay. So, the lossy compression is a type of data encoding. Okay, it is like a encoding that initially discards some data during the compression process. The lossy compression method filters and discards unnecessary and redundant data to lower the quantity compressed and then executed on a computer. Digital multimedia such as audio, video, photos and streaming data benefits from lossy data compressions. So maybe these are the lossy compressions will be there, maybe because these are the large amount of data may be there. So large amount of data is available. So that is the reason maybe the data loss will be occur. So the sizes of these forms of data can be significantly decreased by utilizing lossy compression, ensuring convenient internet distribution of or online consumption. So the lossy compression works by removing any excessive or redundant data from most multimedia files. A JPEG or example can be shrunk by 80% of its original size without scarifying of visual quality. Okay, so this can be accomplished by lowering the pixel count, brightness, and color density. Similarly, background audio sounds are removed from MP3 or MPEG without affecting the end user experience much. So when we are going for the lossy compression, this lossy compression are the best examples are the JPEG. So 80% of data is available. Maybe the chances are there means 20% may be loss. It is a maximum amount of data. So this JPEG image can be shrunk by 80% of its original size without sacrificing of visual quality. Okay, the visually is good, but background of maybe the 20% of data maybe will be lost, but visually it is okay. But accomplished by lowering the pixel count, the brightness and color densities may be changed, but background audio sounds are removed from MP3 and MPEG without affecting the end user experience. Why? Because we are removing audio sounds are removed from MP3 MPEG without affecting the end user means maybe if I am getting the lossy compression, maybe the data loss will be occur. So that is the problem with lossy image compression. So majorly data compression methods are two types majorly. So these data compressions are, first one is a lossless method, that is a text or program. Second one is a lossy methods, that is a image, video and audio. So this image, video and audio, large files may be there. Large files can be occur. So that is the reason maybe the lossy can be occur. So this lossless methods, lossless means text or program. So text or program we can't lose anything, that is a lossless. Okay, example are the RAR files, okay, zip files like this. So these are the files are security. Okay, we are securely archiving that files. So that is a lossless method, and the loss methods are image, video and audio. So in the lossless methods there are three types are there: run length coding, Huffman coding and Lempel-Ziv coding. So these are the three types of lossless, and the lossy images are three types: JPEG, MPEG and MP3. These are some examples are there. Majorly there are so many are there, but major things we are discussing. So data compression methods. Data compression means it is nothing but a image compression. It is also called image compression. So these image compressions are two types majorly: lossless method, that is a text or program. Lossy methods means maybe image, video and audio. So lossless methods are three types: run length, Huffman, Lempel-Ziv. And lossy images are maybe three types: JPEG, MPEG and MP3. These are the three types of lossy images. So what is lossless compression? So lossless compression entails compression the data so that when the compression is reversed, the original data set is fully recreated. This differs from lossy compression, in which some data is lost during the reversing process. Lossless audio compression is another form of lossless compression. When we are going the various files such as executable programs and code modules, lossless compressions means that all of the data in a compressed formats must be entirely recreated or decreased. Then the compression is reversed. This service is provided by technologies such as zip file tools, resulting in fully reconstructed data sets after unzipping the files. Okay, so when we are going for the lossless compression, that is when we are going for the zip files. After then we are going for the unzip files. So unzip files are converting the zip is converting to the unzip files. Why? Because we are data compression is there. data compression, but no data loss. So this lossless compression entitles suppress the means reducing the data. Suppressing means we are reducing the data size, that data, so that when the compressing is reversed, the original data set is fully recreated. It is compressed. After decompression means output. So that is a data set is fully recreated. In that lossy compression, some data is lost during the reversing process. Maybe the data loss will be there when it is a reversing process. But lossless audio compression is another name for lossless compression. So when I'm going for the audio, video and images, so maybe these are the type of lossy files. But some various files such as executable programs and code modules are lossless compression, means that all of the data in a compressed format must to be entirely recreated when the compressed is reversed. This service is provided by technologies such as zip file tools, resulting in fully reconstructed datasets after unzipping the files. Okay, when we are giving the zip files means it is the compressed. Okay, unzipping means decompressed. Decompressed means the output decompressing. When we are going for the input of the data, we are going for the zip files or compressing the image. So in contrast, some data loss after compression may be acceptable for music, images or videos. So when we are going for the music, images or videos, these are the lossy files or lossy compression. Maybe the chances are there, not all the conditions, maybe the chances are there for lossy compression, because these are the large file sizes, very large file sizes. Okay, and because even though the quality of the media may be impacted, these formats will still be consumable and helpful despite minimal data loss. Lossless compression is achieved using a set of highly advanced algorithms. These include modeling the data for compressing to see how much storage space may be saved without impacting the dataset's reconstruction. Experts point out that various lossless compression algorithms operate in different ways. So when we are going for the lossy, I'm talking about lossy. So these lossy are the size, the file of the sizes are very high, and the lossless compression is achieved by using a highly advanced algorithms. Okay, we are using some algorithms to remove the lossy of the data, or we are avoiding the lossy of the data of the original image, and the compression to see how much storage space may be saved without impacting the dataset reconstruction. So the data saving also very important. So the data saving with algorithms. The expert's point of view, the various lossless compression algorithms operate in different ways. So lossless compression can be defined as a technology that reduces the storage requirements while preserving the data integrity. Some of these algorithms functions on the idea of plausible versus importable data building, in which algorithms anticipate or forecast or how datasets might be put together to reconstruct a file. A closer examination or lossless compression algorithms reveals that many operating on the notation removing or copying the duplication. So when we are going for the lossless compression, the data will be no loss. Already we know that, but these are the algorithms are preparing to lossless images. But the lossless compression can be defined as a technology that reduces the storage requirement. Less storage we need, and these algorithms functions on the idea versus probable data building, in which algorithms anticipate or forecast how data sets might be put together to reconstruct a file. A closer examination of lossless compression algorithms reveals that many operate on the notation of removing or copying with the duplications. Duplications are important. Why? Because maybe the data loss will be chances are there. Data loss maybe data loss occur. So these are the lossless compression, and these techniques can make the files smaller while offering a short, and the machines can use the reconstructing the data later using strategies like bit string substitutions and data conversion. These are the various approaches around this, including using helpful pointers to provide consistent values for extra data bits. So whatever may be, when we are going for the lossy or lossless compression, what is the main thing is a data compression. What is the main thing means data compression. So these techniques can make the files smaller while offering a short, and machines can use or reconstruct the data later using strategies like bit string substitution and data conversion. There are the various approaches around this, including using helpful pointers to provide consistent values for extra data bits. So data bits are, we are counting for, depends on our data bits. Maybe the loss is there or lossless is there of the image. We will find out. So what are the difference between lossy compression and the lossless compression? So the following are the highlights are important, are the different differences between lossy compression and lossy compression. So first we are taking as a keynote. First one key, second one is a lossy compression, third one is a lossless compression. So what is a keynote? First one is a data elimination. So is the possibility of data elimination is there? We have to see in the lossy compression. So in the data elimination from lossy compression, by using lossy compression, we can rid of bytes that are regarded as a unnoticeable. But when we are going for the lossless, it is a unnoticeable bytes are retained with lossless compression. Okay, so it is a read bytes of data. Maybe the loss is there. It are the retained with lossless compression. Unnoticeable bytes are retained. Retained means reverse back. Okay, so reconstructed or recompressing. So restoration is possible in the lossy. After lossy compression, a file cannot be restored in the original form. Why? Because it is a lossy now. Lossy means the data will be lost. There is no chance of restoration. But lossless means the data may be lost, but restoration is available. Here, restoration is available from the original form. And what is the quality of that? When I am going for the lossy compression, the quality suffers as a result of lossy compression. It leads to some level of data loss. Okay, so maybe the chances are there for the quality is reduced. Quality is reduced. Why? Because data loss is there now. So that is the reason maybe the quality will be decreased. But here no quality degradation happens in lossless, because it is a lossless, but means no data loss. No data loss. So quality is good. So in the differences of lossy and lossless compression, first one is a data elimination. In the data elimination, lossy compression, the data may be lost. In the lossless, it will be not data loss is there. Restoration means here the data is lost and there is no possibility of restoration. But in the lossless, the restoration is possible. The data loss is there, but restoration is possible from the original form. When I go for the quality of that one, it quality suffers to a result of lossy compression. It leads to some level of data loss. But here, no quality degradation. Here, the loss is there now. So, maybe the quality will be decreased. Here, no quality will be lost. Why? Because it is a lossless. And another one is a algorithm used. Is it using the algorithm here? So, transform coding, discrete cosine, transform discrete wavelet, transform fractional compression, etc. These are the algorithms are used in lossy. When I am going for the lossless, run length coding, Lempel coding, Huffman coding, arithmetic coding, these are the algorithms are there. Algorithms are using in lossless. Okay, what about the size? So lossy compression reduces the size of a file to a larger extent. Lossless compression reduces file but less is compared to lossy compression. Okay, the file size maybe chances are there to reduce, but here it will be reduced but not much as lossy. And what about the uses? Lossy compression is used to compress the audio, video and images. Okay, when we are going for the audio and video image applications, the uses are there. But when we are using the lossless means when we are going for the files, means what file, data file or programming data. These are the programming files are there. No? So these programming files will be compressed. These are called text, program code and other such critical data are there. That is called lossless compression. And what is it about the capacity? The data holding capacity of the lossy compression approach is quite significant. So capacity is higher or not? Yes. But where? In the lossy or lossless? The data holding capacity of the lossy compression approach is quite significant. But in the lossless compression has low data holding capacity. Low data holding capacity as compared to lossy compression. Okay. Maybe the capacity is high, here the capacity is low. Why? Because the data loss will be there now. So maybe the capacity will be increasing. Here there is much capacity to hold the data for some time for comparing to lossy. And what are the major differences between lossless and lossy data compression? So both lossless and lossy data compression techniques are used to compress data. What are the major things means to compressing the data from its original size. The main difference between lossless and lossy that we can restore the lossless data in its original form after decompression, but lossy data can be not restored in the original form of decompression. Okay, lossy means no restoration, but when we are going for the lossless, the restoration is available. Restoration is available. That is in the lossy. Lossless is a restoration is available. In the lossy, there is no restoration is available. So some more differences of lossy and lossless comparison. Lossless data compression. In lossless data compression, there is no loss of any data and quality. No loss of data. Why? Because it is a lossless. But here lossy means the data may be lost. How much? In loss data compression, there is a loss of quality and data which is not measurable. But in the lossy, the file does not restore its original form. Why? Because it is a lossy means not restoring, not restoration. No restoration process. But here restoration is available. So in the lossless data compression, algorithms are run length encoding, Huffman coding, Shannon-Fano encoding, arithmetic coding, Ziv-Welt encoding. These are the lossless. But when you're going for the lossy data compression, algorithms, transform coding, discrete cosine transform, discrete wavelet transform, and the fractal compression, etc. These are the lossy. And what are the lossless compression is the mainly used to compress text, sound, and images. Text, sound, and images means audio, video and images. But lossy compressions are mainly used for audio and video images. As compared to lossy data compression, lossless data compression holds more data. Comparing to lossy and lossless, lossy data compression holds more data. Lossless data compression holds more data. Compared to lossy data compression holds less data. So lossy will compress more data. So the file quality is high in the lossless data compression. The file quality is low in the lossless data compression. When we are going for the lossless data compression, mainly supporting raw data, BMP, PNG, WAV, FLAC, and ALAC files are the lossless. And lossy data compression mainly supports JPEG, GIF, MP3, MP4, MKV, and OGG files are the lossy data compressions. So, what are the major things of lossy data compression and lossless data compressions are? In lossless data compression, there is no loss of data. In the lossy means the data partially, the data loss will be there, but in the quality, somewhat it will be different from the lossy. And in lossless, the file restores in its original form, but in the lossy, the files should not be restored in the original form. In the lossless data compression algorithms, there are different types of algorithms are using in the lossless. That is a run length coding, Huffman coding, Shannon-Fana coding, arithmetic encoding, and the Welk encoding. These are the lossless. When I'm going for the lossy data compression algorithms, transform coding, discrete cosine transform, discrete wavelet transform, fractional or fractal compression, etc. are the lossy data compression. When I'm going for the lossless compression, is mainly used to compress text, sound, and images. When I'm going for the lossy compression, the mainly used in audio, video, and images. As compared to lossy data compression, lossless data compression holds more data. As compared to lossy data compression holds more data. When I'm going for the lossy, compressing less data. When I'm going for lossless, compressing more data. Those are the differences. And what is about a file quality is high in the lossless. The file quality is low in the lossy data. Why? Because already the data is missing in the lossy. So that is the reason maybe the file quality will be less compared to lossless. And the lossless data compression examples are PNG, RAW, flag, and ALAC files are the best examples of lossless. And the lossy are the data compressions are mainly supports JPEG, GIF, MP3, MP4, and OGG files are the lossy data compressions. So, lossy compression leads to some level of data loss and degradation in quality while decomposing a file back to its original form. However, it can be used effectively to compress multimedia and image files in order to reduce their size in great extent so that they can be easily transported over the web. Moreover, the data degradation is tolerable to certain extent in multimedia files. Lossless compression, on the other hand, is used to compress file containing text, program codes, and other such forms of data where any data loss would make to the files useless. So, majorly we are going about the loss and lossless. So, when I am going for the lossy, the levels of data loss, degradation of the quality. Lossy may be quality not good. Here, good quality. And it is used to effectively compress multimedia and image files in order to reduce the size of a great extent so that they can be easily transported over the web. Moreover, the data degradation is tolerable to a certain extent in multimedia file. Lossless compression, on the other hand, is used to compress files. Okay, in the lossless compressing files contain text, program codes, and others such as data where the data loss maybe make files useless. So lossless means compressing files, that is the program code and text data like this. Loss of data means MPEG and JPEG, GIF, etc. are the lossy images. And it is an example or block diagram of lossless coding image. First one is the input to compressed image. It is a figure A. So it is the input to output. Input is a original image. Output is a compressed image. That is I am taking as a, suppose here f of x, here it is a g of x, Here compressed image is a g of x. Here output is a f dash of x. So finally we are getting f of x equal to f dash f x. So what are the stages are there? From the original image input stage, if you are going to the fn, summation, plus to minus, predictor and the nearest integer. So predictor will be predicting the input data, and the integer means we are adding the data, and f dash of n, it is adding the predicting value and image value. It is a symbol encoder, means we are converting to the binary. So symbol encoder nothing but a binary conversion. So compression image is always when the image in binary form only. If image in binary data, then only compressing is possible. Okay. After the compressing of image, the output g of x. So when we are going for the figure B, compressed image, that is a g of x symbol decoder, means converting from binary to data. That means D to A, here A to D. So D to A, it is summation. Predictor means we are predicting the original image, and the decompressed image means original image. So input is the original image, output is the original image. But meanwhile, what is happened means, meanwhile the image is compressed and decompressed. So f of x to f dash of x. So what is happening means, f of x tends to g of x and g of x tends to f dash of x. But f of x to g of x is nothing but a compressed image. G of x to f of x is a decompression of the image. So like this, input to output compression original image to the decompressed image. But first stage figure A, compressed image, figure B is a decompressed. Overall figure is a figure A and B is combining, that is a lossless coding image. Figure A and B, lossless coding image. So the input image with the predictor, nearest integer, symbol encoder and a compressed image. So in the symbol encoder, it is converting from A to D. From the compressed image, it is the digital data is there. So this symbol decoder means converting from digital to analog. Predictor is a analog form. It is a f of n. Already here f of n is there. No? This f of n is complete here. There. Here e of n is there. This e of n. So errors or prediction values are there. So decompressed means original image without any of the noise, or decompressed or compressed image. That is a output image. Another one, a lossy predictive coding model. It is a encoder. Figure A is a encoder. So input image, output is a compressed image. But what is that means here? It is a lossy. It is the lossless. So lossless and lossy. So what are the stages are there? In the input image, f of n, predictor, quantizer, e of n, symbol encoder means LR to digital conversion. Compressed data is in the form of data in digital form. So this predictor is converting from analog to digital, same digital to analog. So this predictor is converting from digital to analog. Output is a analog. So digital to analog. Again input image and it is there. But what is means here compressed image? So compressed is the output image. But I need a decompressed. So if I going for the decompressed image, again you are going to the symbol encoder, decoder, predictor like this. So it is a lossy predictor. In the lossless predictor, nearest integer, symbol encoder, compressed image, symbol encoder, predictor, decompressed. But in the lossy image encoder, quantizer, symbol encoder, compressed image. But here I am going to the summation, predictor and output image. These are the references. So here today we discussed lossy and lossless data compressions. So lossless is nothing but a error free. Lossy means maybe the error is there, due to that reason maybe the data may be lost. So compression techniques are two types: lossy compression and lossless compression. And image compression involves reducing the amount of data bits required to represent a digital image. This is done by removing the redundant information. And image compression is crucial for efficient storage or retrieval, transmission and manipulation of images. More generally, data compression involves the efficient representation of data in digital format. So best example is the information theory. So the compression can be either a lossy or lossless. So this data compression is a technique or using an algorithm to reducing the noise in the data, or error free. If you are going for the error free, that is a lossless. If you are getting some errors and that maybe the data loss will be there, that is a lossy. And these are the techniques are there. And what is a lossy compression? Lossy compression is a type of data encoding and compressing the data intentionally discards some data during the compression process. So in the digital multimedia, audio, video, photos and streaming of data are the lossy data compressions. The sizes of these forms of data can be significantly decreased by utilizing lossy compression, ensuring convenient internet distribution of offline consumption. And the lossy compression works by removing any excessive or redundant data from the most multimedia files. If I'm taking the JPEG, okay, this JPEG is a best example of lossless, but 80% is no data loss, but 20% maybe occur due to errors. So this can be accomplished by lowering the pixel count, brightness and color density. Similarly, the background audio sounds are removed from MP3 and MPEG without affecting the end user experience. So data compression is majorly two types: lossy and lossless. In the lossless method, best examples are the text or program. Run length, Huffman and Lempelsive are the lossless methods, and the lossy methods are JPEG, MPEG and MP3. So lossless compression is nothing but there is errorless. There is no error in that one. So what are the lossless images are there? So when I going for the music images, video and audio are the lossy images. When I going for the program files, text data, that is a lossless data. So the lossless compression can be defined as a technology that reduces storage requirements while preserving the data integrity. Some of these algorithms functions on the idea of plausible versus importable data building. A closer examination of lossless compression algorithms reveals that many operating on the notation of removing or copying with duplication. These techniques can make the files smaller while offering a short, and machines can be used to reconstruct the data later. And there are the various approaches around this, including useful, helpless, or pointing to provide consistent values of extra data bits. So there are major differences of lossy and lossless. What are the key points are there? First one is a data elimination. Is what about data elimination in lossy and what about data elimination in lossless? By using lossy compression, we can rid of the bytes of the data regarded as uncountable. Lossless means unnoticeable by the retained data loss will be compressed. Restoration. In the lossy, there is no restoration of the data. In the lossless, the restoration is possible from the original. And what about the quality? If the lossy of the information is there, that is the quality is low compared to lossless. Lossless quality image is good compared to lossy. And size of this one, maybe the size will be reduced because of the data loss will be there in the original image. In the what about lossless means the size is normal, and we have to change possibility. And algorithms are used. There are different types of algorithms are used in lossy and lossless. And the data transforming coding, discrete quotient coding, discrete wavelet, and the fractional compression techniques are the lossy compression algorithms. Run length encoding and Lemperl, Huffman coding, arithmetic encoding are the lossless encoding algorithms. And lossy compression uses are audio, video, and images. Lossless compressions are used to compress files containing text, program codes. These are the best examples of uses of lossless. And what about the capacity? The data holding capacity of the lossy compression approach is quite significant, and the lossless compression has low data holding capacity as compared to lossy compression. So, what are the major differences of lossy and lossless? In the lossless data compression, the data no loss is there, but in the lossy data, the data loss is there and the data compression is available. Maybe the compression of the data is changed. In the lossy, the restoration is not possible, but in the lossy, the restoration is not possible. In the lossy, the lossless, the restoration is possible. In the lossless data compression, codings are run length coding, offline coding, share and fan coding. But in the lossy coding, there are transformation coding, discrete coding, fractal compression, etc. Lossless compressions are mainly used to compress text, sound, and images. Lossy compressions are mainly used to compress audio, video, and images. As compared to the lossy data compression, lossless data holds the data more data. In the lossy, the data holds are very less, and the quality of the image or quality of the data is very less in the lossy, and the quality is very good in the lossless. And what are the best examples of data of lossless is a raw, BMP, PNG, and lossy is a MP3, MP4, and GIF, JPG are the lossy. And it is a block diagram of lossless coding image. Figure A is a compressed image, figure B is a decompressed image. And a lossy predictive coding model is a encoder model. Here predictive coding for lossy compression. Lossy compression means data loss. So input image, quantizer, symbol encoder, and output is a compressed image. That is the G of n. So f of n equal to G of n, input image, compressed image. So when you are going to the G of n predictor, it is a f dash of n. So it is a lossy predictive coding of encoder. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.